Hello, this is Matt Gaskill presenting Philosophy 160, Problem 1.18.17. So we've got, the problem is a question of associativity. We have this connective kind of shown by the section symbol. They called an associative, and they have this argument of uh, two arguments here, where we've got an A connective B, but inside parentheses, and then that connected to C. And then we've got where we've shifted the parentheses over to the right. So now it's A connected to parentheses, B connected to C, close parentheses. And then we want to look at each of the different operators to see if they are associative. Can we move those? In other words, can we move those parentheses around and still result in the same uh, truth value? And so we've got just our general operators, our ands, our ors, our exclusive or, our material consequence only if, and then we've got our biconditional, our if and only if. And the question is, are they associative? And we're supposed to do it using truth tables. And so what we've done is we are going to compare each of these two arguments um, against each other in each of the cases where we swap out the connective, the section symbol there with each of these different operators. And so what we've done is we got one, two, three, four. We've got five of these to look at, and so we've got five truth tables that we're going to look at. And so we'll just kind of walk through. If you saw the video on problem 1.18.8, then this will look very familiar. If you didn't, then go ahead and go back to that one and watch that first, because there's a lot of kind of insider trading knowledge there. It'll be a good investment for you to do. So I would stop here, go watch that video, and then come back and pick it up here with this one. So that said, so in the first one, we're swapping in the and operator wherever we saw that a connective. We've just swapped it out, and we've got the two cases. We've got where the A and the B are in the parentheses, and we've got where the B and the C are in parentheses, and then we just swap out that connective with the and, the conjunction operator. And then, like we did in 1.18.8, we just fill out the truth table. So we've got three letters this time, and so our truth table is 8 rows instead of just the 4. But we still create it the same. So the way you create this truth table, you start at the right side, the rightmost column of this set here, and then it always goes TF, 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 all the way down. No matter how many rows you have, it's just TF, TF, TF. And then you go your next row over, in our case B, and it'll go 2 T's, 2 F's, 2 T's, 2 F's, etc. And then you double again when you go to the next column to the left, and you get 4 T's, and then you get 4 F's. And then in our case, we're done. 3 variables, 8 rows. That's our standard truth table for that situation. And so like we did in section 8, in problem 1.18.8, we'll just fill in the columns. We just transcribe the value from, for A, for each row. So in this case, it's a T. So here it's a T. Down here, it's an F. And so we do an F. And so we just copy it on over. Same for B, same for C. And then you can do that all the way across. Just fill out all your A's, your B's, and C's. Fill out what you know. So what we know is we know A, B, and C. No thought required there. Just transcribe it over. So you get an F there for that C, for instance. And then you have to work your way from inside parentheses to outside parentheses. And so the next thing we can do over here is answer the question, A and B, and then we do. And so are A and B, are they both true? Well, yes, they are. And so then we enter a T there. And then you'll just do that all the way down the line, down the column. And now that we've answered, that question, then the only question left is the dominant operation, the dominant and so we'll look at the value. Remember, we can only use values once, and so to answer that true question, we had to consume those two, the A and the B, left and right values, and we consumed those, and then they became at T. So you can only use them once. So only this T now is available on the left-hand side. The right-hand side, we haven't used it yet. And so we're going to compare that left T to that right T. Are they both true? They are. And so then the value is true. So if we kind of go down the line, here's a false and a false. They become false. And a false and a true becomes true here. False and true is still false. Same idea on the right-hand side. We fill out the A's, the B's, and the C's. We do the parentheses first. We end up with our values in that column. We've consumed, by that point, the B and the C values have been consumed, so only that the final value of what's inside the parentheses is available to us. And so that is our right input for the question of this AND operator. So we use the left input as our A, the right input is the first AND operator. And because those are both true, then this value is true. And you do it down the line. And because they map over each row, TT, FF, they're all on any given row, the resulting logical value is the same. And so that means that it didn't matter where the parentheses were. And so it's associative. We do the same approach for each of the operators. So here we have the exclusive OR, for instance. And so you just, again, you fill down the columns just as we did, and answer the parentheses first, and then answer the dominant operator. But remember that you have to use the resulting value from the work that you did within the parentheses. So once you've evaluated A and evaluated B, in order to determine this exclusive OR is false, then you've consumed those left and right inputs. They can't be used anymore. So the only value available on the left is that false value, and we use it with the true value, and we ask exclusively OR, is the left or the right true, but not both? Yes, then it's true. So the answer to that exclusive OR is true. And you do that on the line, and again, you end up with the same situation as we had originally with the first problem, and each row results in the same truth value, meaning that the location, the placement of those parentheses, whether they were around A and B or if they were around B and C, it didn't matter. It didn't change the result of our truth table. And so they're associative. And then we've got the inclusive OR. It's the same thing. Some of the values switch around. You can see we got a lot more T's in those rows than we did with the exclusive OR, but nonetheless, the main thing is each is row by row is the same value. It's associative. Now here is the interesting one with the material consequence. You can see immediately, because I made them red, that the truth values sometimes change depending on where the parentheses are. And so that means you can't just move parentheses around. It's a different question if you move them around. And so material consequence, the only if, is non-associative. And then the last one was the biconditional, and you can see there's no red font. And so that tells you straight away that it is associative. So the only material implication is non-associative. So just be careful of your parentheses, particularly when you're using when you're working with the material consequence, the only if, the right arrow. All right. If you have any questions, as always, hit me up on Pronto. Thanks.